7CL. Today we're going to learn about energy transfers. So what is electric power? Power is the rate of electrical energy, so it's the rate at which it's transferred by an electric circuit. And this equation is what we use. Power is equal to energy transferred divided by the time. So that's where the rate of electrical energy comes from. But power also has another equation. It has the equation power is equal to current times voltage, or PIV. So power can either be energy divided by time, or power can be current multiplied by voltage. If we use Ohm's law, we can get another equation for power. Remember, Ohm's law is the equation that relates voltage, current, and resistance together. So if we know V is equal to IR, we can sub this into here, and we can get P is equal to I times IR. I times I is I squared, and R is just there. So power can also equal current squared multiplied by resistance. So here are three different equations for power. Okay, I'm going to have a quick unit and symbol checker. So the symbol for power is just a capital P, and it can have unit watts or joules per second. The symbol for voltage is a volt, and it can have unit volts, which is just, again, a capital V. The symbol for current is I, and it has a unit amp because it's measured in amperes by an amperemeter or whatever it's called. You have a symbol for resistance, which is just a capital R, and the unit for resistance is an ohm. And these are some equations, just to recap on how we got from here to here using V is equal to IR, putting that into PIV, and then we got P is equal to I squared R. Now we've got this new equation, E is equal to Q times V, which states that energy is equal to the charge times the voltage. Okay, so energy is equal to charge times voltage, but this comes from the fact that if power equals energy divided by time, and if we remember that Q is equal to quit, current times time, we can sub Q into this equation. Energy equals IT multiplied by V. And by using PIV, that power is equal to the current times voltage. So let's rearrange this so that makes sense. IV times T. We can say that if power is IV, sub power in for IV, power times time. So this equation is found by combining all of them, because we know power is equal to energy transferred divided by time. If we rearrange this, if we rearranged power equals energy divided by time, multiply both sides by time, power times time equals energy. So what we found is this equation is actually not something that's new. We know all of it from all the equations that we've looked at before. So yeah, again, remember that the unit for energy is a joule. I'm just going to introduce quickly the national grid. So power is transferred in a national grid. You can see them through these loads of cables and transformers linking power stations to the consumers, so to us, and electrical power is transferred. So you have step up, and this is an increase in voltage from the power station to the cables. And this step up in voltage improves heat loss because you have a smaller current flowing. Remember Ohm's law. And then the step down is the decrease in voltage, so the cables to us. So for domestic use, 230 volts.